Use the quotient rule to derive the derivative of tangent of x. All right, well, first things first, what is tangent of x? Tangent of x is the same as sine x over cos x, right? So I'm going to need the quotient rule for this. So if I label u and I label v, the quotient rule would be the d dx of u over v is u prime v minus v prime u all over v squared. In other words, the derivative of the top times the bottom minus the derivative of the bottom minus times the top all over v squared. So let's see what happens. So let's take the d dx of sine x over cos x. All right, let's do that. Just writing it out. Okay, so that's going to be u prime v. Let's actually go over here and find out what u prime, v prime, and v squared is. U prime is going to be the derivative of sine, which is cos. Okay, very simple. And v prime is going to be the derivative of cos, which is negative sine, also very simple. And then v squared is going to be cosine squared, so we'll say cos squared. Now that we have that, let's plug it all in. U prime is cos x, so cos x times v, which is cos x again, so cos squared, minus v prime, which is negative sine x, so there's a double negative right there, very interesting, times u, which is sine x, all over v squared, which is cos squared x. Okay, cosine times cosine is cos squared x, minus a negative, so plus sine x times sine x is sine squared x. And that's all going to be over cosine squared x. Now, I know what you're thinking. Oh, a cos and a cos, they cancel out. No. This is actually what happens. There's a Pythagorean theorem identity that says cos squared x plus sine squared x equals 1. That comes from the unit circle back in pre-calculus, boys and girls. So this whole numerator turns into 1. And that's all over cos squared x. Well, we know also from pre-calculus and geometry and all that good stuff that 1 over regular cosine is secant. So 1 over cos squared is secant squared x. So after all of that, the derivative of tangent x is secant squared x. And we did that using the quotient rule. Isn't that neat? Use the quotient rule to derive the derivative of secant x. All right, well, what is secant x? Secant x is 1 over cosine x. So what I'm going to do is I'm going to label u, I'm going to label uv, and I'm going to remind myself that the quotient rule is the derivative of u over v is u prime v minus v prime u over v squared. So let's go off to the side and say, all right, well, using that information, u prime is going to be the derivative of 1, which is nothing. V prime is going to be the derivative of cosine, which is negative sine x. And then v squared is going to be 2 cosines, one multiplied to the other, so cos squared x. All right, so let's put it all together. The d dx of secant x is going to equal u prime v, so 0 times cosine x, that's going to make life easy, minus v prime, so minus negative sine, so a double negative right there off the bat, u, which is 1, all over cos squared x. Like that. All right, so things cancel out. Okay, u go away. Double negative is going to become positive sine x over cos squared x. So let's kind of split this up into something slightly more manageable. All right, I have one sine up here. I have two coses down there. So let's just, for this example's sake, split it up like this. Okay, this is perfectly fine. Because I'm trying to think like, all right, well, there's got to be a way that I can simplify this, and there is. So if I say sine over cos, I know that sine over cos is tangent. And I know that 1 over cos is secant. And so when all is said and done, I have my answer. The derivative of secant x is tangent x secant x. So, or some teachers might say secant x tangent x. It's the same exact thing. But when all is said and done, that's what I get. And we figured that out using the quotient rule. Fun, fun, fun. Use the quotient rule to derive the derivative of cosecant x. Well, what is cosecant x? Well, that would be 1 over sine x. And if I'm going to use the quotient rule, I'll label u and I'll label u v, and remind myself that the derivative using the quotient rule of u over v is going to be u prime v minus v prime u all over v squared. So let's find out what u prime, v prime, and v squared are. U prime is going to be the derivative of 1, which is nerfing. V prime is going to be the derivative of sine, which is regular cosine. And then v squared is going to be sine squared, so sine squared. So let's put it all together. All right. The derivative of cosecant x is going to be u prime v, so 0 times sine x, that'll be nice, minus v prime, so cosine x, u times 1, all over v squared, which is sine squared x. So let's make things go away. 0 times sine x goes away. Okay. Negative cosine x times 1 is negative cosine x. And that's that. All over sine squared x. So let's split this up into two parts just for example's sake. All right, I have negative cosine x over one of these sine x's, and I'm going to multiply that to 1 over the other sine x. Okay, we know that negative is negative. Cosine x over sine x is cotangent x, and 1 over sine x is cosecant x. And there's nothing more I can do with that, so I'm done. So at the end of the day, we could say that the derivative of cosecant x is going to be negative cotangent x times cosecant x. And some professors or teachers might have it backwards. They might say negative cosecant x, cotangent x, but it's all good. It's all the same. But we did that using the quotient rule, and boy, was that fun. Use the quotient rule to derive the derivative of cotangent x. Well, what is cotangent x? Cotangent x is the reciprocal of tangent, right? And so since tangent is sine over cosine, cotangent is cosine over sine, like so. And if my job is to find out the derivative of that using the quotient rule, then I'm going to label the numerator u and I'm going to label the denominator v. Because the quotient rule states that if I take the derivative of u over v, I'm going to find u prime v minus v prime u all over v squared. So what is the derivative of each of these parts? Well, u prime is going to be the derivative of cosine, which is negative sine, like so. V prime is going to be the derivative of regular sine, which is regular cosine. V squared is going to be sine squared, so sine squared x, like that. So let's put it all together. The derivative of cotangent, that's a cosine, that was a close one, that was a close one. The derivative of cotangent x is going to be u prime v, so negative sine x times v, which is regular sine x, minus v prime u, so minus cos x, u, which is cosine, all over v squared, which is sine squared x, like so. Excuse me. Now, negative sine times regular sine is negative sine squared x, minus cosine times cosine is cos squared x, all over sine squared x. Now what I'm going to do is I'm going to factor out a negative 1 on the top. And I'm going to be left with sine squared x plus cos squared x. Now why in the blazes would I do that? Well, there's a Pythagorean identity that says that sine squared x plus cos squared x is just 1. So I get negative 1 times 1 up here over sine squared x. Negative 1 times 1, let me get out my calculator, is negative 1, so let's pull the negative out, and that leaves me with negative 1 over sine squared x. And if 1 over sine is cosecant, then 1 over sine squared is cosecant squared. So let me write that out. So when all is said and done, I know that looks a little bit sloppy, when all is said and done, the derivative of cotangent x is negative cosecant squared x. So not the prettiest looking thing in the world, certainly not, but the quotient rule gave it to us, and boy wasn't that a lot of fun. If f of x equals secant x minus cosecant x, then f prime of x is what? Well, this is just a matter of memorizing the derivatives of secant and cosecant. There's no attachments here, none at all. The derivative of secant is going to be secant x tangent x, so let's write that out. Secant x tan x minus the derivative of cosecant is negative cosecant x cotangent x, like so. And all we have to do here is just kind of simplify that double negative. So secant x, I like parentheses, it just looks prettier, tangent x minus a negative plus cosecant x cotangent x. And there's really not much more you can do. If you're going to try to be cute and factor and simplify, just don't worry about it. This is just a matter of memorizing cosecant and cosecant and secant and cosecant, and then just writing stuff out and doing the double negative, and we're done. Find dy dx at x equals pi when y equals secant x times ln of x. Ugh. All right, so this is not going to be pretty at all. In fact, I think this is actually not going to be so bad. This is what's going to happen. We're going to need the product rule for that guy right there. All right, so product rule, if you forget, is the ddx of u times v is going to be u prime v plus v prime u. So what I need to do is figure out what u prime is, right? U prime is the derivative of secant. The derivative of secant is secant x times tangent x, right? V prime is going to be the derivative of ln of x, which is just 1 over x. So coming back over here, right, we can now kind of put things together. dy dx is going to equal u prime v, so secant x tangent x times, oh, did I do the v? No, times v, so times ln of x, not pretty, plus v prime, which is 1 over x, times u, which is secant x. Okay, so dy dx is going to equal that. So let me actually erase that. I don't really need to simplify anything. There's nothing in here that needs to be simplified. There's nothing we could do. It's just now what we have to do is plug in pi. So if I plug in pi, I end up with secant pi, tangent pi, ln pi plus 1 over pi secant pi. So pi's everywhere. It's like Thanksgiving. All right, so hopefully we remember this stuff. Secant of pi is -1. Okay, and of course that comes from the fact that you have 1 over cosine pi. So secant pi is -1. Tangent pi is nothing. So I don't really care what ln of pi is because it's just going to disappear anyway. Plus 1 over pi. Secant pi, again, is -1. So you completely cancel out, and 1 over pi times -1 is -1 over pi. So that's going to be my guy right there. So we used product rule to figure out this stuff. We plugged in pi a bunch of times. We really only needed it once. And yeah, that's our answer. Fun stuff. What is the derivative of f of x equals sine squared x over cos x with respect to x? So this is what I'm going to do. I'm going to split this up. I'm going to split this up and make this sine x over cos x times sine x, right? Sine x over cos x is tangent, and sine is just sine. So now what I'm going to do is I'm going to view this as product rule. I'll call you u and I'll call you v and remind myself that d dx of u times v is u prime v plus v prime u. Right? The derivative of u is the derivative of tangent, which is secant squared x. Memorize that. V prime is going to be the derivative of sine, which is going to be regular old cosine, no negatives. So now this is just a matter of me putting together the product rule. U prime v is secant squared x times v, which is sine x plus v prime u, which is going to be cos x times tangent. Now, knowing what I know, let's simplify these a little bit and see if anything magical happens. It's possible. I'm not sure, but let's just have some fun with it. Secant squared x is 1 over cos squared x, okay, times sine x plus regular cosine x. Oh boy, that looks terrible. Cosine x times sine over cosine x. These guys cross out. Okay. Nothing special happens here, except if you want to, you can say that 1 sine over cosine is going to be tangent. And since that leaves you with 1 cosine on the bottom left over, we can call you secant. Okay. Plus sine. And after all of that, that's basically all I can do. There's not much more I can do after that. I mean, nothing simplifies. I mean, there's no use in factoring any signs out because that would just turn you, I don't know, we're done. So after all of that, tan x, secant x plus sine x is going to be the derivative of that guy right there. Nifty, nifty, nifty. Find dy dx at x equals pi over 4 when y equals 3 sine x cos x plus 2 tan x. Ugh. All right, so this is what I'm looking at. Okay, u, our product rule. So u would be my u, 3 sine x would be my u, and cos x would be my v. You're just regular old, trig identity stuff that I don't have to lose any sleep over, so I'm not going to worry about you. Let me remind myself that the product rule is the d dx of u times v is u prime v plus v prime u. So, when I do this guy, if I called u 3 sine x, then u prime is going to be 3 cos x. V prime is going to be the derivative of cosine, which is negative sine x. So y prime is going to start out by me doing u prime v, so 3 cos x, v, which is cos x again, how nice, plus negative v prime, so negative sine x u, which is 3 cos x. No, it's not. It's 3 sine x. Sorry, kind of snoozed there. That was a close one. Ooh, boy. Ooh, boy. And then plus 2 times the derivative of tangent is going to be 2 secant squared x. Now I have to plug in pi over 4. Okay, so let's clean this up just a little bit. This is what I don't want to do. What I don't want to do if I'm going to plug in pi is make these squares because it throws my brain off. I'm going to keep this as y prime equals 3 cosine x cosine x, because in pre-calculus I memorized these guys but with sine and cosine and tangent only. So I'm not going to go crazy trying to do secants and stuff like that. I can, but I won't. Minus 3 sine x sine x. And what I'm going to do is make this plus 2 over cos x cos x. All right? Y prime, when I plug in pi over 4, so y prime of pi over 4 is going to be 3 cos pi over 4 cos pi over 4 minus 3 sine pi over 4 sine pi over 4 plus 2 over cos pi over 4 cos pi over 4. Now, if you remember from the unit circle and stuff like that, cos pi over 4 is root 2 over 2. So you're going to be 3 times root 2 over 2 times root 2 over 2 minus, also, this is nice, sine of pi over 4 is also root 2 over 2 times root 2 over 2. Now, why is this good? Because you're thinking, oh man, I have to multiply all that. No, I don't. 3 times root 2 over 2 times root 2 over 2 minus 3 times root 2 over 2 minus times root 2 over 2 goes away because they're the same exact thing. And we're left over with 2 over root 2 over 2 times root 2 over 2. All right? So 2 over square root of 2 times the square root of 2 is going to be the square root of 4, which is 2, over 2 times 2, which is 4. So I get 2 divided by a half, which is the same thing as 2 times 2. And after all of that, you get 4. So isn't that lovely? It sure is. Kind of a weird, crazy problem, but yeah, that does it. And I believe that does it for Unit 2 for my videos. So I hope you're watching all of them and liking and subscribing. Please, I beg you.